Thank you very much for the speeches. All speeches were very interesting. Indeed, what I realize here is that there are two things, major things that will enable this technology. One is protocols. So we have to standardize the protocols that these devices communicate between them. And the other thing is energy. So what is the advances in energy? I mean, since most of these devices are wireless, I suppose that energy harvesting is one of the major things that can boost this economy. So are there any advances in the technology of energy harvesting that can be used for in the IoT industry? And what about protocols? There used to be, I think, protocols like Zigbee and Z-Wave trying to standardize the way that these devices communicate, but it seems that protocols are still not very close to becoming standard.
Well, I will take the question of protocols, because from the harvesting energy point of view, we're not really doing anything innovative. So from the protocols point of view, what we're seeing as the problem is not the Zigbee, the Wi-Fi, Bluetooth, etc., but the protocols that sit on top of them. So we need to find a way for the devices, whatever technology they are using, whatever frequency and so on, the protocols that they are using in order to communicate with each other to be common. So this is the way that we are seeing the problem here, because the technologies will exist, because each of those technologies has something to offer that the other technology does not offer at the level that the one is doing. So we think that all the technologies will exist in the future. The problem is that the protocols that sit on top of those.
You mean like on the software level, like HTTP?
Yeah, right,
or,
right. Yeah, right. Right, and or in between TCP and HTTP and Wi-Fi, Bluetooth, and Zigbee, for example. So or even at the top of those. So in the protocols that sit on the top of HTTP, and let's say from the time that the Bluetooth reaches the network, so if you have a Bluetooth device, it will not reach the network by itself. It has to use a gateway, like a mobile phone. So the mobile phone has to use a protocol that is common with a Wi-Fi sensor, and this is the level that we're seeing that the protocols have to be common.
You want to go for the energy?
Okay, so the energy harvesting issue is quite challenging, and many research groups in Europe, and especially in US and Japan, are trying to address that problem. The RF harvesting approach, meaning that you transmit wirelessly energy using electromagnetic waves, there are two issues. The first issue is sensitivity. What is the minimum power needed in order to harvest power? And right now, the limit is on the order of minus 20 dBm, 1/100th of a milliwatt, essentially. That's the limit, around that. And the problem is that the technology used is a 100-year-old technology, is a rectenna, is basically a diode and a capacitor. That's all you need in order to do RF harvesting. The problem with the diodes are basically the materials that we are using right now. The materials that we are using right now give you that limit. So if we want to have more sensitive RF harvesting devices, we need to devise new materials. And people are working on that right now. The second issue with RF harvesting is efficiency. Not all the power that is being induced on the antenna can be converted to useful power. One portion will be converted to useful power, another will be lost. That's why we're talking about efficiency. Efficiency right now is a function of how much power you have. It's a nonlinear function of the incoming power. It's a matter of design. So those two problems, sensitivity, are not 100% addressed in the most elegant way. It's a matter of research. We have to do a lot of work. Regarding the other issues that you mentioned, I don't agree that it's a matter just of gluing technology together. I try to show today one gap of technology. Okay, Zigbee technologies, traditional wireless technology right now cannot be used directly for the Internet of Vegetables. Okay, so I try to solve this problem using creating new technology using scatter radio, etc. So it's a matter of creating new technologies as well, especially in the last mile. In the last mile part of the applications, bringing data to the cloud. After you bring data to the cloud, I agree with you that it's a matter of protocols, it's a matter of nice GUIs, it's a matter of nice SDKs, and so forth.
Next question, please. Please, go ahead. There is a microphone right where you're sitting.
I would like to ask you something about the standardization of the protocols. Is the new Bluetooth low energy technology can be considered as a standardization with the private and public services it has? So you can transmit information that many devices of different manufacturers can recognize?
Well, I think that the Bluetooth LE is just one more technology that what is adding is the low energy part. From that point of view, it's not something that will solve everything. I mean, you should still use Wi-Fi for streaming large amount of data. So it depends actually on the application. So it will not be able to stream video from a Bluetooth LE device. And the Internet of Things video is part of the Internet of Things as well. So as I told earlier, it's not a matter of protocol. Protocols, from our point of view, are going to exist to coexist in the future altogether.
May I ask something to Mr. Bletsas? We saw before a very nice project that you're doing with plants, but my question is for the ecological point of view, and has to do with what's the effect that has all the plants with the transmitters, with the reflectors, with all the stuff that you use. Even we, as people, using routers, Wi-Fi, etc., such things, were affected. How about plants?
Okay, so thank you very much for the question. In order to network a greenhouse, I need one receiver, which is passive, doesn't transmit anything, just receives. I need a couple of emitters. I'm talking about the greenhouse. I'm talking about the deployment that we did. It was a 30 by 30 meters greenhouse. So we used just two emitters, and one receiver. And we had about 50 tags that, as I said, do not radiate anything. They just reflect. So you had two emitters, which were transmitting 1/10 or 1/20 of the power that you are using in your house for your Wi-Fi router. So the technology, the scatter radio technology, it's a passive technology that basically piggybacks information on top of carrier waves already in the atmosphere. So it's the most ecological, in your point of view, approach in order to do wireless networking. Let me elaborate more on this. Last August, the Best Paper Award at SICOM was given to ambient backscatter, which was basically by static scatter radio, exactly the same way I showed it, but without a dedicated emitter. The emitter was the TV station. And you know, in US, the good thing is that emitters are transmitting on the order of 20 to 100 kilowatts. So the emitter was not a dedicated emitter. It was an emitter already there. And the receiver was a very simple SDI receiver, very close to the plant. Why? Because you had a large distance from the emitter to the tag, so you should have a small distance from the tag to the reader.
Leonardo, is that this industry, in order to grow, you have to enable the developers. So I'm very glad to see what you're doing with Econis, because it seems to me you're doing the same thing like what they did with the Arduino and the Raspberry Pi, that they enable the developer community on this small scale, let's say, hardware device. And now you're doing this on the micro scale. So if you're able to enable the developing community, taking out the complexity of the hardware and giving them a platform to develop on it without having to bother with all the techie stuff about how to set up the hardware itself, then these things can actually do the difference for this business. Yes, indeed.
Yeah, actually, it was not the question, right?
It was
The
a
question is
congratulatory
just a statement.
Yeah. Well, thank you, because I take it as a feedback, and it's great to know that people are thinking on the same way that we are thinking. And that's true. And this is what the market has shown so far with in other technologies and in other markets, actually, like the mobile phone market and so on. And this is that if you do not engage the developers, then you will not see the market growing. And actually, this is the challenge, to make it so simple, so anyone, not actually anyone, but most of the people can engage with this technology.
Oh, yeah, just to reiterate that in the sort of more enterprise computing, then Java has tried to do this a similar sort of thing. So extract itself from the underlying technology and allow programs to be written and run anywhere. Java currently goes down to device level, but it's still not right down small enough. So to back on to what you're saying about the gateways, so we see Java going down to the gateway kind of level, a device that's got sufficient capacity to run it, and we can run the same code from the device right to the database in the cloud. So I think the same approach is going to work in the smaller scales, albeit whatever that technology is going to be, but it needs to be the same.
I have a question for you regarding all the remarkable technologies that you previously talked about. It will be like a simple game, like a quiz. What the Internet of Things needs in order to work is customization. You need to work the technologies about me, otherwise it doesn't make sense. It will have to be based on my cell phone, my house, my car, my whatever. As you well know, my needs change over time. They don't remain constant. And I heard nothing about the bigger player in this market, which is the end user. Because if I need a diploma from MIT to make it work, then I would never make it, I would never buy it. All the technology that you talked about, I can give it, I can find it online for you for $100 or less. There is a very good website called IFTT, it's called If This Then That, and then you can play all about. You can buy the Google thermostat and go online and make routines. But the problem, and the problem nobody in this room most probably has this thermostat, is not the price, is that nobody takes the time and has the knowledge. And of course this audience is not the average audience. But if you try to sell it in another shop, nobody will buy it. They will buy the 20 euro Siemens one. So it's not the products, it's how close you bring it to the end market, to the end user. And nobody addressed this. You might have the best product, but it will only be to the professionals. And this is not the bigger market. So what's your comment on this?
David, do you want to take this? Paul, sorry. Or I take it, yeah.
That was quite a long question.
Yeah.
Sorry. No, my view is that the use cases that you described about the connected home, the cell phone, the way you use that is different from a lot of the engagement that I personally have, which is with large organizations trying to make the Internet of Things work for them from a commercial basis in making their systems work better, to do slightly new, different models to engage with their customers. And that's an approach that is driven by the technology that's out there at that level. On the level of me as a person in my home, the fact that I've got an iPhone 6, and when I bought an Apple TV, to configure it to work with everything that I had, I just had to tap my phone on that device, and it was configured. The choice for that end of the market, I think, is going to be much more an emotional decision that I will make. And I'm not going to worry so much, and it could be that I'm an old git anyway, but I'm not going to worry so much about the underlying technology. It's whether that works in my environment. If I've made that choice to be in the walled garden that is Apple, then that's an emotional choice that I make. And that, I think, is a roundabout way of saying that the consumer market and the enterprise market for what the value that IoT brings is subtly different. And I think the choices and the level of customization, as you put it, which is correct at the personal level, is subtly different at a commercial level. Whether I'm trying to, whether I'm an organisation trying to get value from sensors and data that I get from the way people shop, the way they move around a mall, is subtly different.
If I can add a few comments, Paul, I think you kind of showed that in the architecture that Oracle is taking towards this information tank that you're trying to interpret different ways. Mm-hmm. So I think that's a great question. That's an excellent question because it brings us from the protocol interoperability that we're so much worried about. And I think it's something that if we work hard, it will be solved because there will be pivots between different devices, between different protocols. And when we're done with all our homework, some of the stakeholders will be more out there and requiring more of the market, capturing more of the market. So at the end, we'll only be left with a few protocols to interwork and interrelate between. But semantic interoperability, it's something that's a problem that's not going to go simpler. It's only going to go larger. I think this is one of the real challenges of Internet of Things. Because, Paul said that, the value of Internet of Things comes of these networks of this billion of devices, okay? So this is the challenge. This is the value. It's not how to optimize a single device, how to make it cheaper. Of course, it's a lot to be done there, but maybe this lies in the area of optimizing sensors or making them specialized and less expensive. But I think the picture that we're trying to talk about, this technology that we're trying to talk about here, is how to interoperate and how to interwork between this billion of devices. And somehow I pointed that out in my introductory remarks that said, you shouldn't be talking about centralized ways of managing these devices. And in your middleware platforms that we're developing, maybe one should be looking into ways of interworking and into forming swarms of objects that somehow automatically and autonomously manage to interwork with a purpose. And this might be a science fiction for the time being, like, it's a set of devices that on the request of a problem, they decide and they negotiate, they're able to solve the problem based on abstract capability descriptions, okay? But I think the real challenge is there. I think, I want to ask you guys, and you, Paul, what are the enabling technologies there? Because this is not sensors. This is not, fast and low power middleware processing on low cost microprocessors. But this lies more on what you presented, Paul, like cloud computing, data management, big data, and this type of technologies.
Yeah, I think it is that, and I think that there will always be, to some extent, as you say, specialised, because there's going to be specialised ways of doing things. So those objects working together in swarm mentality is actually being tested in the oil spill in the Gulf of Mexico. It wasn't big scale, but there was tens and tens of these devices that were just swimming around together, filtering the oil off. And they did that because they were kind of predetermined to do that and react together. So while there's, on the one scale, that there's lots of different things that all need to communicate and talk, there's also a few things that need to be able to do specific actions and work in specific ways. So I don't think there'll ever be one answer for all of this.
That's true.